Coordination compounds. Coordination. I told you coordination covalent bond. Okay, compound. And actually covalent bond means what? Mutual sharing of electrons, right? So because of that, both are get stabilized. I told you that chocolate story. So coordination covalent bond means for the formation of bond, right? Only one is donating, both are sharing. So that we are called as coordination covalent bond. Complex compound. Coordination compounds we can say complex compounds. Complex means what? Complete. So today I'll discuss what exactly, right? Complex compound enti, right? For example, normal salts, double salts, which I'm going to give you right now. Normal salt, for example, if I'm taking the NaCl, NaCl is a normal salt. If you are dissolving in water, right, what exactly happens? Na plus Cl minus. So NaCl while dissolving, how many ions will get? 2. Double salts are there, correct? For example, KCl, MgCl2, like 6H2O, like that. If you are dissolving in water, how many ions will get? Total molecule. Total molecule is dividing into ions. K plus, yes or no? Cl minus, Mg2 plus, like that. Total molecule is dissociating. K4FeCN6. This is my favorite compound. K4FeCN6. So because I keep on telling this example. Okay, let it be. So how many ions we will get after dissolving this? How many ions we will get? Right. This is a complex, right? 4K plus this FeCN6. FeCN6. This is 4 minus. Here is try to understand. Right. This is particularly complex compound. This is particularly complex compound. Complex compound means it won't dissociation takes place. FeCN6 is like that, complex compound or coordination compounds. For example, K4FeCN6. K4FeCN6. This is a complex compound, coordination compound. This is Fe, iron. This is what? Cm, central metal atom. It's coming from D block elements. Cm. Cn minus actually, right? Ligand or ligand. Ligand. Cm we are called as what? Lewis base. Cm, Lewis acid or Lewis base. So vacancy in the d orbitals are there. It's accepting the electrons. It's Lewis acid. Why it's Lewis acid? Because of vacancy in the d orbitals. The total important thing is for the complex compounds, the vacancy in the d orbitals. Lewis acid. Ligand is Lewis base. Lewis base. Right now, this particular, we could say this is coordination sphere. Coordination sphere. So then if we can go with, for example, NaCl is a salt, right? Cation and anion. This is also this particular portion. This is cation. This total we could say anion. Cation, anion. Right? Coordination sphere, central atom, ligands. So already we discussed something about d block elements. In the d block elements, central atom, because of vacancy in the d orbitals, atomic number, so number of how many number of electrons are present, that is important. Already we discussed, that is I'm going to discuss here also. And the next important thing is the total coordination compounds. Particularly 1 or 2 questions are directly asking. Hello. But this total chapter, what is the basic means? Ligand. Okay. What is the basic? Ligand. If we know the ligand, right? we can say it's central metal oxidation state. If we know the oxidation state, we can name it as IUPAC naming. Once we are naming IUPAC naming, we'll get the oxidation state, right? We can write the VBT, how many number of electrons are present, what is its hybridization, what is its structure, which color it is, whether diamagnetic or paramagnetic, how the d orbitals are splitting in octahedral complex and tetrahedral complex, right? So lots of things are there, but for all, if you want to master coordination chemistry, only one thing you need to do, you need to master the ligands. Ligands, right, are different types. Monodentate ligands, bidentate ligands, tridentate, tetradentate, pentadentate, hexadentate. What is dentate? Monodentate means only one lone pair if it is donating. Nana. For example, here is iron is the central atom, right? So cyan is having the one lone pair, it's donating. Coordination covalent bond is forming, right? So this is monodentate. In monodentate, no need to by heart all. No need to by heart all ligands. By watching the ligand, we have to say which type of ligand it is. Monodentate ligands means only one pair donating. Monodentate ligands also, once again, we are going to classify three: negative, positive, neutral. Negative ligands, positive ligands, neutral ligands. For example, Cn minus is monodentate negative ligand. Which ligand? Negative ligand. For example, ammonia is there, NH3. Monodentate means it's donating only one lone pair, but it is what? What, Nana? Neutral. Right? For example, positive, NO plus, like that also. Positive ligands also, NO plus, NO2 plus, like that. So, types, I'm just going to give you the type of ligand. For example, bidentate ligand. What is bidentate? Two lone pairs. For example, for bidentate case, the important thing is ethylene glycol. For example, CH2, NH2, otherwise we can say oxalic acid or oxalate, COO minus, COO minus. It is donating to metal, it is donating to metal. Bidentate. Tridentate means 3. For example, CH3, CH2, NH2, CH2, NH2. Right? This is also bidentate. Means no need to by heart all ligands. What we need to do? We need to identify which type of ligand it is. For example, what is the use if you are identifying the ligand? Same, K4FeCN6. FeCN6. So cyanide is right now monodentate negative ligand, right? Means what? -1. Its charge. So now we need to find out the oxidation state of iron, right? Oxidation state of iron. What is the oxidation state here? We don't know, right? X. So simply you can go like this. K plus, right? It is X minus -1 into 6. -6 is equals to, is -4 into -4. 4K plus FeCN6 -4, right? Total charge -4. Then X is equal to, yes, Nano? +2. X2 +2. So why I am trying to say this one, if we know the ligand, automatically we can find the oxidation state. Once we know the oxidation state, cinema begins. If you don't know ligand, if you don't know the oxidation state, right, how much good at coordination chemistry, it will be 0. right? For example, nickel NH3 taken plus 3. For example, this one. What is the oxidation state of nickel? Right, ammonia is 0, right, total 0. So whatever so nickel is 3 plus, right? So the first important thing is we are going to IUPAC nomenclature for coordination compounds. In the coordination compounds, now already we got, so we got plus 2, right? So while we are writing the IUPAC nomenclature, so compounds, complex compounds are basically 3 types, right? Complex compounds are 3 types. Now in this case, this acts as an anion. Sometimes it acts as a cation, sometimes neutral. So means for example nickel, for example NH3 taken 6, for example SO4. Now SO4 2 minus, here is plus 2. Now plus 2 in this case minus. Now in this case it acts as a what nana? Cation. This is anion. Now in this case this is cation, this is anion, right? For example FeCO taken 5. Like this is neutral. Complex compounds are 3 types. This is a complex. This is a complex. This is a complex. This complex is anion. This complex is cation. This complex is neutral. Now, in this case, for example, the complex is cation. We need to know the IUPAC nomenclature. What? IUPAC nomenclature. Once again, I am just going to discuss each and everything because I am just giving you the introduction. What exactly we are going to learn. What is the importance of this particular one? So K4FeCN6. So first we'll go with this one. Which one? Cation. So then afterwards we'll go with ligand. Third one, we're coming with central atom. So means how we'll write first potassium, right? Potassium 6 means hexacyano. I'll give cyanide, we could say cyano. Negative ligands we always with O. Fluoro, chloro, bromo, cyano, right, like hexacyano. If it is anion, 8 we have to use the 8 we have to use the Cm. What is 8? Ferrate, cuprate, manganate, candate, titanate, chromate, whatever the, right? If anion is there, so we have to use 8. Ferrate, right? And right last 2 is Roman letters. We need to write this, those. The Roman letters, whatever the oxidation state which we are finding, so we need to write in the Roman letters. 3 I think capital, right? 3, 4, 5 like that. If we know the ligand, we can find out the oxidation state. Once we know the oxidation state, we can write the first naming, IUPAC name. Here onwards it starts. Entire coordination chemistry mainly depends on identification of ligand. We need to identify which ligand it is. We had some basic ligands. If you are moving to advanced level, the ligands list is keep on increasing. But in case of mains level, NEET level, we had only some ligands are there. So I'll give the list, right? In this particular coordination chemistry, first we will discuss what is ligand, what is central atom, what is coordination sphere, how many ions are possible, what is double salt, what is right? This complex salt. Then afterwards IUPAC nomenclature. Then we'll go theories. So actually which type of bonding is there in between them. Sometimes I would say the coordination covalent bond, sometimes ionic bond, different types of bondings, different types of theories were there, right? The theories we will discuss. In that particular theory, VBT is more important, valence bond theory and crystal field theory. Then isomerism is there, isomerism. So total only in this particular coordination chemistry, first if you know the ligands, VBT, CFT, isomerism. 4 areas are important. And stabilities of complexes, lot of things are there. But it is, believe me, it is very interesting chapter. Unlike D and F block, of course, we saw different types of reactions, something, right? In S and P blocks also, lot of reactions are there, but lot of syllabus are decreased. So, don't miss the class, right? Follow exactly. If wherever you are not getting anything, so please let me know. We'll go. So I am just focusing, emphasizing how they are asking the questions, and we'll do some previous year questions and all.